Okay, here's yet another video for my students asking about how to calculate resistor values for LEDs. So let's draw a simple circuit. We'll make it a little bit different to the ones I've just recorded. I'm not sure what order I'm going to post them in. There's a resistor, there's an LED, and I'll add another LED. So series or parallel, what do you think? Well, one comes after the other, so they're in series. And we'll have a battery here of 9 volts. Remember, 9 volts or voltage is just known as, or is another term for potential difference, so the difference in value. So if this is 0 volts, this must be 9 volts greater. Okay, so that is a difference of 9 volts. Now, as it goes up there, when it comes down here, it's got to go down from 9 volts down to 0 volts. So there's going to be a drop, and another drop in voltage each time. If we assume these are red LEDs, each one of these red LEDs is going to have a forward voltage drop of about 2 volts. So if it's dropped from something to 0 volts and it dropped 2, then hopefully you can understand that that must, if we go in this direction, it must be 2 volts, and if we dropped from something down to 2 volts, if we go back, think backwards, it's going to be 4 volts there. So in other words, if we just stick a voltmeter there and there, and another voltmeter there and there, this voltmeter would read 2 volts, this voltmeter would read 2 volts, and if we were to put a voltmeter across both of those, that would read 4 volts. The difference. You might think, what's this got to do with the LEDs? Well, it is actually critical that you understand this. So what's the difference now between 4 and 9? Well, hopefully that's fairly obvious. That's going to be 5 volts of difference going across there. So if I were to put another voltmeter, lots of voltmeters now, across here, that's going to be 5 volts of potential difference. Now, what we need to know about is the characteristic of these LEDs. So if they're red LEDs, the ones we use in school most often have a current requirement for moderately bright, of about 10 milliamps, say. Okay, really should have said about 10 milliamps. Okay, could be a little bit more, could be a little bit less, but aim for 10 milliamps and that's fairly safe. So now we know the current going through the lot, because it's the same current in a series circuit that goes all the way through, of 10 milliamps. So we know the voltage that's going dropping across this resistor. We also know the current that's going through the resistor. It's the same 10 milliamps that goes through the rest of the circuit. So we can, using Ohm's Law, calculate the resistor value. So Ohm's Law, quick recap: voltage IR, like that. You sometimes see it like that. So if you want to calculate resistance, finger over there, so resistance equals voltage over current. So the resistance equals voltage over the current, which in this case is 5 volts over the current, which 10 milliamps is 10 thousandths, so that is going to be 0.01 amps, and that's going to be equal to 500 ohms. Okay, I'll just write 500R. If you want, you could write it 500 ohms like that. Okay, now we don't have a 500 ohm resistor. If you look through the resistors we've got in the cabinet on the wall, we've got mostly E12 value resistors. So there's two possible choices. Nearest one's 470 ohms, which would, because it's a low resistance, will give you more than 10 milliamps. Not really a problem, because anything between 10 and 20 milliamps is absolutely fine for the LEDs we use. But if you would like to be a bit more conservative and go for less than 10 milliamps, that will make your battery last longer, then you would have to go up a value. So we have also 560 ohm resistors. So I might decide that that's going to be a 560 ohm resistor there, and then that will allow slightly less than the 10 milliamps that we originally wanted through this one, and each one will have their 2 volts drop, because we got a 9 volt battery, so we can accommodate the fact we've got 2 volt drops here. If, for example, you had a 3 volt battery, you wouldn't be able to have them in series, because 2 volts and 2 volts is 4 volts of drop, where you can't provide that by 3 volts. So then you would have to rewire it in some other configuration. Okay, I'm going to stop the video here. I'll probably make several different videos on LEDs and resistors this evening, so and hopefully one of them will be useful to you.